The field of mathematics is swarming with riddles, unsolved problems. Some have been eluding mathematicians for hundreds of years. One mathematician who has dedicated his life to solving them is Enrico Bombieri, and for his efforts, he's being awarded the Crawford Prize 2020 in mathematics, including 6 million Swedish crowns. The citation reads, "For outstanding and influential contributions in all the major areas of mathematics, particularly number theory, analysis, and algebraic geometry." Milan 1940. Rigoletto is playing at the world-famous La Scala Opera House. Italy enters the Second World War. Bombieri is born here and grows up in the midst of an Italy being devastated by war and rebuilt. He becomes fascinated with mathematics early on, the world of numbers. Bombieri's interest in deeper mathematics started at 15. His father asked for his help in reading An Introduction to the Theory of Numbers. Enrico loved the book and read it from beginning to end many times.
Bombieri was a prodigy who got in contact with leading Italian mathematicians like Ricci already as a teenager. And he was in fact only 16 when he published his first scientific paper.
It was Giovanni Ricci that introduced Bombieri to the Riemann Hypothesis, one of mathematics' greatest mystery, which from that moment on will follow him throughout his life. In 1963, Bombieri receives his mathematics degree from the University of Milan and then continues his studies at Trinity College in Cambridge. Bombieri is there for a brief yet pivotal time. This is where he meets Harold Davenport. Davenport is a leading expert in the field that will become Bombieri's greatest love, number theory. At 25, Bombieri is professor at the University of Pisa, and today Professor Emeritus at the Institute for Advanced Study in Princeton, New Jersey, where he's tackling the great mysteries of mathematics.
Bombieri is an unusually broad mathematician. He works in several areas and made deep and groundbreaking contributions to both number theory, analysis, and geometry.
The mathematical world consists of many different areas. Some are more alike, algebraic geometry and Diophantine geometry, for example, while others, like group theory and partial differential equations, speak such different languages that even mathematicians themselves often don't understand each other. But Bombieri can jump between widely disparate areas and solve the most difficult problems there. One example where Bombieri was involved is the solution of Bernstein's problem. Simply put, when the wireframe is lifted out of the soap solution, a membrane is formed. There is only one way in which this can occur, namely that the area of the membrane becomes as small as possible. Describing it is easy, but proving it mathematically is much more difficult. This is called Plateaus Problem. Bernstein's problem, that Bombieri, along with two of his Italian colleagues, managed to solve, was a more complicated version of Plateaus problem, where several dimensions were involved.
Bernstein's problem was really a hard problem. This is shown by the fact that it took more than 50 years to solve this problem. I should also say that the methods are of interest for other problems related to physics.
Bombieri is one of the foremost problem solvers in mathematics today. But the great mystery still remains, the one which has captivated the greatest minds in mathematics for 161 years, and Bombieri himself from the age of 18, the Riemann Hypothesis.
Ever since its formulations, it attracted the attention of many of the best mathematicians.
I think there are many mathematicians who have spent years to try to solve this problem.
And it's still not cracked, so it's clearly one of the big problems for mathematics.
There are several ways to formulate the Riemann hypothesis, some of which require university-level knowledge, but basically it deals with the distribution of prime numbers. Prime numbers are integers greater than 1 that can only be divided by themselves and 1. At the beginning, they are more common, but as we increase the size of the numbers, the more rarely they occur. They do not follow any pattern, but seem to be uniquely distributed. Therefore, it is difficult to know how many prime numbers are under a certain number, such as, for example, 1 million. In the early 19th century, one of history's greatest mathematicians, Carl Friedrich Gauss, came up with something. He realized that with x divided by log x minus 1, we can get a very close estimate, but not the exact number. Bernhard Riemann took this further with his hypothesis, which, somewhat simplified, stated that the error in Gauss's approximation cannot be greater than the square root of x. So thanks to Riemann, we have a more accurate version of Gauss's observation. Today, 161 years later, no one has been able to prove or disprove Riemann's hypothesis.
Well, Bombieri is certainly one of the leading experts on the Riemann hypothesis. He has not solved it, but he has obtained important partial results that has led to new methods, for instance, in sieve theory.
But what role do these mathematical puzzles play? Why do they matter? Well, for example, the Riemann hypothesis can be used to analyze the acoustics of a concert hall, like Milano's La Scala. But many solutions cannot be directly linked to benefits in our everyday lives. But they are part of the whole of mathematics and its development. What it gives us in the future, we don't know yet. But we do know that it is important. The progress of mathematics is visible in everything from encryption and artificial intelligence to the possibility of predicting the effects of climate change.
Bombieri is a worthy prize winner. He has made stunning contributions to a broad range of mathematical areas, number theory, analysis, and geometry. One has to go back to the classics of the 18th and 19th centuries to get counterparts of his contributions.
It was an absolutely complete surprise. Of course, very welcome and very unexpected. At the same time, it made me extraordinarily happy because my connection with Sweden has been very deep. Mathematics is not something which is useful necessarily. It becomes useful because it's the right thing to do.
The Crawford Prize is awarded in partnership between the Royal Swedish Academy of Sciences and the Crawford Foundation in Lund. The Academy is responsible for selecting the Crawford laureates.